Scientists discovered nearly 40 years ago that human activities were depleting the ozone layer and that a hole had formed over Antarctica. These sobering discoveries galvanized the world to take on an environmental challenge of a lifetime. Now, the ozone hole has come a very long way since its dire predictions in the 1980s, but we can't celebrate yet. Policymakers and scientists are still working together to protect the ozone layer in the atmosphere. So, stay tuned to find out how the globe is working together to repair the depleted ozone layer, along with how it has impacted our world so far. First up, what actually happened to our Earth's ozone layer, and how can we as humanity fix it? Let's take a look. In terms of decades, the 1980s were anything but peaceful. The Great Fall of the iconic Berlin Wall in 1989 reshaped the future, ushering in a new global order. However, another significant but lesser-known event of that decade occurred 2 years earlier, when governments came together to reverse ozone layer damage and ensure we had a viable future to shape. In September 1987, to be exact, the Montreal Protocol on Substances that Deplete the Ozone Layer was officially signed, marking a watershed moment in environmental history. It also demonstrated how science and political willpower can work together to change the world. The incredible story of the fight to save the ozone layer begins with science. Scientists warned in the mid-1970s that man-made chemicals in everyday products, such as aerosols, foams, refrigerators, and air conditioners, were harming the ozone layer. But they had no idea how big the problem was at the time. However, a hole in the ozone layer over Antarctica was discovered in 1985. The natural sun shield that shields humans, plants, and ecosystems from harmful ultraviolet radiation had been breached. And because of this, serious issues like skin cancers, cataracts, dying plants and crops, and damaged ecosystems all loomed large. There was no more time to waste. Scientists had sounded the alarm, and the entire world had taken notice. So, governments around the world began to adopt the Vienna Convention for the Protection of the Ozone Layer in 1985, laying the groundwork for the Montreal Protocol, which aims to phase out ozone-depleting substances such as chlorofluorocarbons, CFCs. The protocol then officially entered into force in 1989, and by 2008, it had become the first and, more impressively, the only UN environmental agreement to be ratified by every country on the planet. UNEP was critical to the success of this process. It mediated the Vienna Convention and has hosted the Ozone Secretariat in Nairobi, Kenya, since 1991. But before we delve further into what's being done to replenish the depleted ozone, let's first cover what the ozone actually is. So first things first, what exactly is the ozone layer? Ozone, also known as trioxygen, is a highly reactive gas made up of 3 oxygen atoms. Some ozone can be found near the Earth's surface, but the majority of it is concentrated in the stratosphere. The ozone is a poisonous molecule to humans at ground level and can harm the lungs if inhaled. At 31 miles above ground, it's necessary and protective. At the stratospheric level, it joins with other ozone molecules to form the ozone layer. Those ozone molecules absorb UV radiation and act as a sunscreen for Earth's life. Now, as we mentioned earlier, researchers discovered that certain substances, particularly man-made industrial chemicals, disrupt ozone molecules. These substances degrade ozone molecules by removing one of the oxygen atoms. These impacts can make the ozone layer less and less stable over time. Additionally, the thinning of the ozone layer endangers human health. Because the layer allows more ultraviolet rays from the sun to pass through and reach the Earth's surface, UVB radiation is especially dangerous because it can cause skin cancer and cataracts. UVB radiation can also harm marine life and plants, as well as reduce wheat, rice, and soybean crop productivity, which we will touch on further on later in the video. CFC's effects may extend beyond the ozone layer. CFCs are powerful greenhouse gases that may have a wider impact on climate change outcomes. CFCs are found in lower concentrations in the atmosphere than carbon dioxide, making them a minor contributor to global warming. While CFCs do not appear to be causing global warming, regional warming presents a different picture. According to recent research, these same gases have accelerated Arctic warming, contributing to sea level rise and surface warming in the North Pole. So this begs the question, what are we doing to fix the damaged ozone layer? It is necessary to ensure that no ozone-depleting gases reach the stratosphere in order to close the ozone hole. Now, the Montreal Protocol, which was signed by 197 countries, is the only real mission working towards repairing our ozone layer. The protocol, of course, has been updated over time to include more substances that could harm the ozone layer and the climate. Hydrofluorocarbons, for example, were added to the list of controlled substances in 2016 because they've been identified as potent greenhouse gases. Since its inception in the late 80s, the treaty is regarded as one of the most successful protocols for addressing human-caused environmental challenge. Now, speaking of these initiatives, is the ozone layer fixed? Both yes and no. The Montreal Protocol has significantly reduced ozone-depleting gas concentrations in the atmosphere, and we mean very significantly. However, according to Laura Ravel, an environmental physics professor at the University of Canterbury, the problem has not yet been resolved. Although the gases have been banned, they are still present. According to various reports, possible illegal CFCs have been detected in the atmosphere, and in 2018, it was revealed that unexpected levels of CFC-11, a type of chlorofluorocarbon, was being found. This concentration of CFC-11 was possibly caused by unauthorized industrial production, which violated the Montreal Protocol. It was then revealed through extensive research that these emissions could delay the ozone hole's recovery. So, as long as countries continue to follow the Montreal Protocol, climate models predict that ozone levels will return back to normal by the end of the century. Now, this is what you should know about ozone depletion and how it impacts us and our environment. The amount of UVB that reaches Earth's surface increases as the ozone layer depletes. Now, if you weren't aware already, UVB is the main cause for non-melanoma skin cancer. Furthermore, UVB has been directly linked to the development of cataracts, a clouding of the lens of the eye. Now, you need to know that cataracts are the leading cause of blindness in the world. If ozone levels were to fall by 1%, the risk of cataract would rise by 0.3 to 0.6%. Oxidative agents can harm the lens of the eye. UV radiation produces oxidative oxygen, which can severely damage the eye lens. UV radiation can also significantly damage the cornea of the eye. Furthermore, like we said, skin cancer can be caused by UV radiation exposure. UV rays alter the structure of biomolecules, resulting in a variety of diseases. Since the skin is the most frequently exposed part of the body to UV rays, it takes the biggest hit. Melanoma is the most serious type of skin cancer and is frequently fatal, whereas non-melanoma is the most common and less fatal. Sunburn and skin cancer are both caused by ozone layer depletion. UV rays are also linked to breast cancer and leukemia. Next up, the surrounding plants. Now, what many people may be unaware of is that UVB radiation not only significantly impacts humans, but it also has a profound impact on plant physiological and developmental processes. Plant growth can be solely and directly affected by UVB radiation. Despite mechanisms to reduce or repair these effects and the ability of most plants to adapt to increased levels of UVB, these changes have the potential to have a significant impact on plant competitive balance, herbivory, plant diseases, and biogeochemical cycles. Ozone depletion also severely impacts our marine life. Additionally, the depletion of the ozone layer also dramatically impacts our sea life. Aquatic food webs are built on phytoplankton. Phytoplankton productivity is restricted to the euphotic zone, which is the upper layer of the water column with enough sunlight to support net productivity. Therefore, solar UVB radiation has been shown to affect phytoplankton orientation and motility, resulting in lower survival rates for these organisms. Scientists have found that ozone depletion-related increases in UVB have a direct impact on phytoplankton production. UVB radiation has been shown to harm the early stages of development in fish, shrimp, crab, amphibians, and other marine animals. The most serious consequences are reduced reproductive capacity and delayed larval development. Small increases in UVB exposure may result in population reductions for small marine organisms, with consequences for the entire ecosystem and the food chain it relies so heavily upon. And there you have it, everything you need to know about what has happened to the hole in the ozone and what the world is doing to repair it as best as we can. Additionally, we also touched on how it got so damaged and the impacts this has on humanity. Do you think we'll be fully able to repair the ozone, or will it forever be damaged due to the current status of the climate and the pollution? Now, let us know your thoughts down below, and as always, thanks for watching.